The third and final type of storage that's supported with ESX is NAS or NFS storage. And this is really cool storage because it allows you to take advantage of disk space that might be available on certain Windows servers that you have, for example, that you're not using. You can use that towards NFS storage, and we're going to talk about how you can do that. But NFS and NAS storage in particular is also relatively cheap, so you can get that for cheaper than you could iSCSI or Fiber Channel, and this is where a lot of the main advantages come into place. And you're also going to lose in terms of some functionality or technology. So this next slide here, I want to talk about some of the differences, what you get with NAS and NFS, and what you're lacking with NAS and NFS. So you can do vMotion, you can do DRS or Distributed Resource Scheduler, you can do HA or High Availability, and you can do VMware Consolidated Backup or VCB. Now what you're lacking, if you compare that to iSCSI for example, you're lacking VMFS. So you won't be able to do VMFS file system on a NAS storage. Now why is that? Now keep in mind, when we talked about NAS storage, we're talking about a storage device that is being presented from a host. So it's a file level storage, it's not a block level storage. We're going to talk about that in a second in the next slide. But another thing that's also missing, if you take a look at Fiber Channel, you won't be able to do any kind of Microsoft clustering services as well. And the final thing that you won't be able to do is RDM or raw disk mapping. So you won't be able to present a raw LUN that's presented from NAS to a virtual machine so that it can treat it as local disk. Whereas with iSCSI and Fiber Channel, the same way you would treat a physical machine and present it with a LUN from the SAN, you can do the same thing and present a LUN to the virtual machine and can take advantage of it. So NFS is a file level transfer of data over standard IP networks, so which means you can take advantage of existing infrastructure, put up a NAS device. That NAS device is going to present a block of storage. This block of storage will be treated as file level instead of block level because the host that's presenting it is the one that's managing it, and whoever you're presenting it to won't be able to manage it. They'll only be able to take advantage of it as available space. Now NFS is to Linux what SMB or Server Message Block is to Microsoft Windows environments. The same way you can have shares on Windows, you can have the same thing with NFS. So NFS is to Linux was what SMB is to Windows, for example. Now by default, ESX Server allows 8 NFS data stores. However, you can configure that to go all the way up to a maximum of 64 data stores. And I'll show you later on when we log on through the VI client where you can go to up that value if you need to go beyond the 8 data stores that are provided by default. Now as far as the NFS components are concerned, if we start at the top, we have ESX, which is the host that has a standard NIC adapter. The standard NIC adapter in turn connects via standard Ethernet cable, Cat5, Cat6, to an Ethernet switch again via Cat5 or Cat6 to the NFS device. This NFS device is what's holding the storage and what's presenting the storage on the network, making it available for ESX to connect to this storage. Now as far as NFS connectivity goes, the same way we configured iSCSI, so we won't be going through the same exercise. The same way we configured iSCSI, whereby we created a virtual switch and added the VM kernel port group, the same way you can use the same virtual switch to gain access to NAS. As a matter of fact, all we have to do now that we have iSCSI configured and we have a NAS device obviously on the network somewhere, we can go in and configure connectivity or access for this host to the NAS storage, and we're going to do that in a second. Now as far as failover and failback is concerned, the same rules that apply to iSCSI apply to NAS and NFS, whereby you can take advantage of NIC teaming or multiple switches. The same rules that we discussed for iSCSI apply here as well. Now let's talk a little bit about NFS and Linux. Now the Linux operating system is the native home obviously to shared directories accessible via NFS. NFS directories are defined and configured through the etc exports directory on the Linux-based NFS server, and the etc exports must define the trusted hosts, the directory name, and the parameters. Alright, so now let's move on to some really cool stuff. How do we take advantage of a Windows server that has a lot of disk space that we don't know what to do with? We don't know how to allocate this space, we're not using it for anything, and we want to use this for NFS, or we want to turn this into NFS. So in any typical environment today, because disk is so cheap and because most of the environments now have SANs or some sort of SAN, you end up with local disk on Windows Server that's not being utilized. I think that the minimum disk that you could buy today for servers is 72 gig. If not more, it's probably 160 gig is the minimum that you could probably buy each disk. And if you have a pair, if you're mirroring or if you're doing RAID 5, then that increases the disk space availability. But still, if you have 70 gig and only 20 gig is being used, that leaves you with 40, 50, 60 gig that you could take advantage of. So most of those servers have a lot of free disk space, and we're going to talk about how we can turn this disk space into an NFS storage that we can present to ESX. So the first thing you want to do on the Windows server that you want to turn some of its space into NFS is you want to go ahead and Google Windows services for Unix. You're going to come to a download. It's a package. You download it, you basically install it, and we're going to go through some of the steps. I didn't want to demo this here because I didn't want to light up the focus on this particular issue, as this is kind of secondary to ESX. But for you guys that want to play around, this is a fantastic little thing, fantastic little project. Another project I would strongly recommend that you try is a free product that's called Ware NAS. Ware NAS is one word. Go ahead and Google that. You could download that. I tried that. I tried installing that inside of a VM on VMware Workstation on my local PC and created a NAS server out of it. It works fantastic. You could take that Ware NAS, and it's very, very small footprint, by the way. You can install it on any server that you're not using, or an old server that you can use just for storage. Turn that into an NFS, put it over the network. Whether you're using this for home or even in your organization, is just a fantastic little application. Again, try to Google it. It's called Ware NAS. Alright, so once we've downloaded and installed the file services for Unix, again, go ahead and do a search for Windows services for Unix. We're going to enable NFS sharing on the folder, and we're going to show you how we're going to do that in the next steps. We're going to copy and import the etc group and the etc password files from an existing ESX server, and I'm going to show you how you could do that. And we're going to use a VM tool called FastSCP to connect Windows, or even to do Windows to Linux or Windows to ESX communication, and then ESX to ESX communication. Just a fantastic little tool from VM, which is one of our sponsors. But put that aside. That's not why I'm plugging this. This is a tool that I actually use on a day-to-day basis, and you're gonna find it extremely handy when you're trying to transfer files from and to an ESX server, especially if you have a lot of those files on a Windows-based operating system or machine. Now, once we've imported etc group and etc password, what we're going to do is we're going to map the Windows administrator to ESX root. What this means is you'll be able to pass the credentials of Windows administrator to ESX root. We're going to synchronize them, so to speak. And after that, then we're going to go ahead and add an NFS storage. Now, from this entire exercise, we're going to go through slides about how to install and configure this. Alright, so once you've installed the Windows services for Unix and you create any folder wherever you want it located on your Windows operating system, once you right-click that folder and go to Sharing, you're going to notice that you now have a new tab called NFS Sharing. Now, within NFS Sharing, you can configure the share name. Now, be careful to share name here because share name is case sensitive. Because I'm a Windows guy, I had to learn this the hard way. If you put NFS, for example, the way we have it on this screen, capital NFS on capital W Windows. If you try to access this with all lowercase, you won't be able to access it. So, pay attention, mind your capitalization here. Now, once you put the share name, you can go ahead and go in permissions and then set the right permissions that you want. Once you install the Windows services for Unix, you get an MMC console, kind of similar to what you're seeing here, it's really cool actually. I'm going to let you guys play around with it. But if you go to username mapping on the left and you click on that, then towards the middle of the screen where you see user network information service, beneath that you have user password and group files. So this is where you would once you copy over the password and group files from an existing ESX server, let's say you put them on a directory on your C drive called Linux files, and then you put both files in there, then you'll be able to browse from here and specify those files. Those are the files that are going to tell this Windows server which groups and which users to map, which groups and which users exist on ESX. It gives it the opportunity to map these groups to Windows users and Windows groups. And let me show you what the mapping looks like. Now, on this screen, you're going to see that we've highlighted administrator, and we're mapping that to root. So on the right here, you're going to see all the users and groups that we've loaded from that user and groups file and then on the left here, you're going to notice that we're looking at all the local users and groups that are available on a machine that we call manager. You'll notice that up there where we have the whack whack and then manager. Alright, now this time you're ready, you have everything configured, and you're ready to present NFS storage to your ESX servers. Now, before we go ahead and log into the VI client and start doing some of that stuff, what I want to do is I want to skip over to one more slide, show you some command lines on how you can create NFS data stores using the command line, and then we can go into the VI client. That way we'll be done with the presentation part. Alright, so on this slide there are steps that you can follow if you wanted to create NFS access through command line. Now I'm not going to go ahead and read everything to you. I'm sure you guys can read. So I'm just going to keep the slide up for a few seconds here. Now you can feel free to pause the video anytime you wanted to do these steps or follow these commands from a command line. They're available to you. Let's go ahead and log into the VI client and let's attach an NFS device or an NFS storage to ESX. So we're inside the vSphere client here. Now at the beginning of the lecture and the beginning of the module, I told you I would show you once we logged into the vSphere client where you can go to modify the maximum size of allowed data stores or allowed NFS data stores. So what we're going to do is we're going to go to hosts and clusters, and then we're going to click on the configuration tab. I told you guys we were going to live inside the configuration tab, and then we're going to click down here on advanced settings, and we're going to click on NFS, and we're going to scroll down a little bit to where we can find how we can modify that maximum, and there it is. And you'll notice that by default it's set to 8, so you can modify this with a maximum of 64 and click on OK down here. So we're going to cancel out of here. Like I mentioned to you before, NFS and NAS follow the same rules and requirements as iSCSI. So let's just go ahead and go into the networking piece here and just double check that we have a virtual switch with a port group that allows us access to IP storage. So I'm going to click on properties. Now earlier on in the module when we were talking about iSCSI, I'm sure some of you noticed that I entered the IP address for IP storage incorrectly, so I have fixed that. But the port group here, as you guys might have noticed, the port group we created for IP storage when we were doing iSCSI, that same one can be used now to do NAS. So now let's go ahead and add some NAS. So what we're going to do is we're going to click on storage. We're going to click on add storage, and this is where you select NAS or NFS. We're going to click on network file system. We're going to click next, and we are going to put in the IP address of the NAS device and the directory. Now keep in mind here, what did I say? Mind your capitalization. So we have NFS on Windows here. I'm going to mount this as read-only so that we can't make any changes to this. This would be a great idea if you had ISOs, if you wanted to share stuff, but you didn't want anybody to make any modifications. Just mount it NFS read-only. Now the data store name that we're going to give this, let's give this NFS1 for now. I can't seem to be able to type these days for some reason. Click on next. Yes, we're sure. And there it is. NFS1, it's mounted as read-only. There you go. Now if you expand this a little bit, you're going to notice that this is the NFS that we're mounting, the share name, if you want to call it. This is how much free space is available on this thing. That's a lot of free space for a Windows box. And then you can see the type is NFS, so it's going to clearly identify the NFS device from the type that you see here. And that's it for NAS, NFS. That's all there is to it. It's very simple, very straightforward. It's awesome stuff. I invite you to play around with NAS and NFS. Experiment with it, whether it's for ESX or for anything else. It's truly a great technology that you can take advantage of. And we got plenty of servers, plenty of PCs that have a lot of disk space that we don't know how to make accessible to the network in an easy way, easy format. This is perfect for that kind of stuff. Alright, so this part of the module, or the storage module, we're going to dedicate to VMFS. This is really cool stuff here. Now, as I've been telling you all along, VMFS is a proprietary file system built for optimal execution of virtual machines that are available on local storage, fiber channel storage, or on iSCSI storage. And as you should know by now, VMFS is used for the storage of virtual machines, of their ISO files, and their templates. And to continue on with some basic guidelines and some stuff that you know, every virtual machine that's created on a VMFS data store will be stored in its unique folder, and this folder will be named after the virtual machine name. So whatever the virtual machine name, that's what the folder name is going to be. Now VMFS data stores can be managed either via the VI client connecting to a virtual center server, or via the VI client connecting directly to an ESX host, or obviously via an SSH session. Now the way that you would identify or reference VMFS data stores is one of three ways. You can either reference it via its friendly data store name. So for example, in the figure down here, you're going to notice that the data store name is shared VMs, or via the four-part device name, or via the unique ID assigned by the ESX host. Now we're going to log into PuTTY in a second, and I'm going to show you the unique ID that's assigned by the ESX host to every data store. But before we do that, let's go through this lecture real quick. Now, earlier I said the four-part device name. Now you can see it here, and the highlighted friendly name is LUN3, for example. The device name is going to be VMHBA1031. That's going to be the four-part device name. Now, the cool thing about the ESX assigned name is that when we browse, when you go through PuTTY, for example, or an SSH client, and you're browsing through the directories, you're going to browse through the volumes directory, and it's going to look like this. Every data store is going to have a friendly name attached to it. So at the far right here, you're going to see, for example, LUN10, LUN21, LUN23. Now LUN21 being the friendly name, and then before that in orange, that set of numbers that you see, it's alphanumeric, by the way. That is the unique ESX assigned ID to every data store. And I'll show you how you can see this unique ID either via PuTTY or from within the VI client. You can find it both ways, browsing it through PuTTY or looking at it through the VI client. We'll get into that in a second here. Alright, so let's launch the VI client and let's go ahead and create a data store, and then we can go through the multiple configurations that we've been talking about here. Earlier on during this module, I told you once we logged in and we were talking about Fiber Channel and VMFS, I would show you where the storage adapters would be. And I'm sure you figured it out by now, but just in case you haven't, this is where storage adapters would be. And then you're going to notice that I have a Fiber Channel HBA card in this server. Now, what we're going to do is we are going to create a VMFS that is available on one of the LUNs that we've presented to this ESX host. So let's go ahead and click on storage here, and what we're going to do is we're going to click on add storage, and we'll be adding a disk LUN. The second option would be used to connect to NAS or NFS, and we will do that. And you're going to notice that I don't have any LUNs. So what do? I can't see any LUNs. So what we're going to do is we're going to click on cancel here. We're going to go back to our storage adapters, and we're going to do a rescan on the storage adapter in order to see if we can see the LUNs on it. And we're going to keep both options checked. Click on OK here, and voila, you're going to notice that we are seeing a lot of LUNs that are being presented to this ESX server right now. So let's go ahead and go back into storage, and then let's click on add storage, disk LUN again, and there you go. At this point, we're going to have to choose which LUN we want to format as VMFS. Let's go ahead and take this one. We're going to click on next, and let's name this thing prod1. We're going to click on next here. We're going to keep these at the defaults. Now this is where you can select the maximum file size and block size among the options. Now the options that you have are as follows. You can do 256 gig block size, you can do 512, 1024, 2048. Now as best practice, you want to leave the maximize capacity option enabled. Contention occurs at the LUN level, not at the partition level, so you want to leave this at the default. We're going to go ahead and click next here, summary, and we're going to click on finish. And voila, there you go. Now if you go to the summary page here, you're going to notice that you have a new data store called prod1, which we've just created. Let's go back into configuration for a second, and let's talk about the friendly name that we were talking about. So the friendly name for this LUN that we've just created, for this VMFS data store that we've just created, is what? It's prod1, exactly. However, what is the the ID that the ESX host is giving this VMFS data store. You can see that over here. So now let's go into the properties here for a second. Now again, you'll notice the unique ID that the ESX host has specified. I'm going to minimize this in a second. We're going to bring up PuTTY, but let me show you inside properties here. Again, you'll see the friendly name of the data store. You can always change that. We're going to come back in here when we start talking about extents, but these are the properties that you can check for the actual VMFS data store that you've just created, the VMFS file system version, maximum file size, the block size, etc. Alright, so let's go back. Let's get out of here. This is the ID, and let's go and launch PuTTY. Alright, so we've logged in. Let's go ahead and go up to the root here, and then let's go do a cd/vmfs, and let's go into cd/volumes, which is the repository for where all the volumes are located. Let's do a list here. Alright, so I'm not supposed to be putting a slash, so let's just do cd volumes, and then let's do an ls here. Alright, so you're going to notice here that the friendly name, again, of the data store is prod1, and then the ESX assigned ID would be as such. So let's go back into our presentation here real quick and talk about extent grow and volume grow. Alright, so with vSphere, there are now two ways of trying to expand a volume. There's what's known as a volume grow VMFS, and what's known as an extent grow VMFS, which is the traditional extent grow that we've seen. So a volume grow allows you to expand an existing VMFS. It allows you to expand the storage where the VMFS is on. So the difference between a volume grow and an extent grow is with an extent, you take another LUN, you carve up another LUN, and that LUN can be on the same physical storage, or it can be from a different array, and you just logically group them together in order to create a bigger VMFS volume. With volume grow, when you're trying to expand it, what needs to happen in order for you to do that, there needs to be adjacent space that's available on the same disk, whereby you can grow into that space on the same disk. You cannot take space from another array or from another separate LUN or format a LUN. It has to be on the same disk, and you're just expanding into it. So you're easily just taking that space, absorbing it, and growing your VMFS volume that way. Now with volume grow, and as you'll see in some of the next slides that we're going to talk about here, volume grow allows you to go up to 2 terabytes. You cannot go more than 2 terabytes with volume grow. Now you can the same restrictions that are available on the extents also are available on volume grow, whereby you cannot shrink a VMFS if you grow it. If you grow the VMFS, then the only other way for you to shrink it is going to be by destroying it and recreating that, and losing data if you have to, if not backing it up, etc. Now if you're doing a volume grow, you're not required to take the data store offline or take any of your virtual machines offline or any of that sort. So it's not an intrusive or interruptive task. You can do that without affecting production or performance. Some of the reasons you do volume grow is if you want to add more spindles. If you're growing across multiple spindles on the same disk, you can improve performance, etc., etc. And it's depicted in the figure that I have here. You have LUN 21 that's in red all the way to the left, that's already using 200 gig, and adjacent to that there's LUN 21 also. The same disk, same LUN, has another 100 gigabyte of free disk space, so you can grow into that disk space and have LUN 21 at 300 gig. However, if you take a look at extent grow, the difference with extent grow is that you are adding a separate LUN. You're taking a LUN, so here you have on the left LUN 21, and then you have a completely different LUN 22 that's coming from anywhere else in your storage environment, and you are logically configuring these two to become one VMFS data store. So they can be on separate disk, etc., etc. They're completely separated. You're just logically configuring them to be one. And that's the picture that's depicted here. Now with extent grow, now because a lot of you are going to be, well, why would I want to do extent grow and not volume grow? Volume grow seems to be always a better option. Well, that depends, because with volume grow it's a better option if you're trying to grow up to 2 terabytes, and if you happen to have adjacent disk space that's next to this disk that you have, then yes, you can grow into it. But in some cases, and if you want to grow beyond the 2 terabyte limitation that you have on the data store, you wouldn't be able to do that using volume grow. The only way you would be able to do that would be to use extent grow. Now, the way you would do that with an extent grow, because you're still limited to 2 terabytes per data store, but you have up to 32 extents, and each one of these 32 extents can be 2 terabytes. So you can have a data store of up to 64 terabyte. Now, the downside to doing that is if you have more than one extent, those extents are now reliant on the primary extent. And the reason for that is the primary extent is going to hold all the locking mechanisms, all the records, etc., etc. So if you lose that primary extent, you're going to lose everything on that store. You're going to have to go through a very intensive recovery process that, trust me, isn't going to be a lot of fun. Now, with extent, the same way as with volume grow, it's not intrusive, so you can add extents without bringing down your data store or taking any of the virtual machines offline. You can also add up to 32 extents again, and each extent can be up to 2 terabyte in size. Now let's take a quick look here at a comparison chart. Now you'll notice that you have extent and you have volume grow, and what are the differences? Now with an extent, you're adding a new LUN, so that's why there's yes for that checkbox. With volume grow, you're not adding a new LUN. Again, you're just extending or growing into existing space that's adjacent. It's a new partition with the extent. It's not a new partition with volume grow. VM state changes. The VM state will not change, as in the data store is not going to go down. The VMs, if they're powered on, you don't need to power them down. Now, as far as maximums are concerned, and for those of you that are taking VCP4 exam, this might come in handy. Again, with extent, you can have up to 32 extents with 2 terabytes in size each. So you can have larger data stores if you're using extents, but keep in mind you're relying on that primary extent. With volume grow, you can only grow up to 2 terabytes, but you can grow this as many times as you want. So let's say you grow it the first time up to 1.1 terabyte, and then you grow it again up to 1.2, 1.3. You can keep growing it as many times as you want, but up to 2 terabytes. And then the dependency, again, like I said, with an extent you have a dependency on the first extent. With a volume grow, you don't have any dependencies because you're just growing into existing space on that disk. So we're back in the vSphere client, and what we're going to try to do now is we're going to try to extend prod 1. So I'm going to go ahead and click on it to select it, and then we're going to click on properties. And you'll notice down here that I can increase the size. Now, once you increase on the size, it's going to give you the available LUNs. Now I need you to focus your attention a little bit on the expandable here to the right. Now, if the expandable here to the right had said yes, if the option was yes, that means that this particular disk space or storage is adjacent to the original LUN that I'm trying to extend or grow. If that said yes, I would be able to grow the volume rather than add another extent. Because expandable says no, that means the LUN that's being presented to me, this particular LUN, is not adjacent. It's not on the same disk. It's coming from somewhere else. Thereby, when I add it, I'll be adding it as an extent, not as growing the existing volume. So if I select this and I click on Next, it's going to give you kind of a brief description of where it's coming, its capacity, its location. We're going to click on Next. Now over here, you can choose to take the full capacity of this disk. So if you wanted to do 10 gig, you can do 10 gig completely. Or you can uncheck this and, for example, select, let's do 5 gig. And click on Next. Finish. Now in a few seconds, you're going to notice that even here, it's going to add this new LUN, as you notice here, to this VMFS volume. If you click on Close, you can focus your attention here. Automatically, it expanded this VMFS volume to about 15 gig. We originally had about 10 gig, and now we added another 5 gig, so I have about 14.5 gig of usable disk space. Now, what can I do if I want to grow this further? Now, if I want to grow this now, instead of adding another extent, what I can do is I can click on Properties again, and we can click on the Increase here again. And you'll notice that automatically this time I have yes. And the reason for that is when I added the first extent, we didn't choose to take the full capacity. And the reason I did that is that because I wanted to show you how you can grow into a volume. Now this is not the same thing because I'm growing into an extent, but it's the same concept. If I had adjacent space on the original LUN, then I would be able to grow into it. So if I select it now, and I click on next, again I can accept this. Now I can take, again, whatever is remaining on this disk by selecting the maximizer. Again, you can uncheck and select whatever disk you want. But we're going to keep it at default, and we're going to finish. So traditionally, what would have happened, like in the ESX 3.5 days, you couldn't do this, you would have added another extent. So here, what we're doing now is you'll notice automatically it's back up to 10 gigs. So it didn't add a third extent, it just grew into the remaining space. So we're going to click on close, and you'll notice here that I now have about 20 gig of usable disk space. Now if we go back into properties, and as I was telling you guys during the presentation, there's no way for you to delete any one of these extents. So I can right click it all day, you can try all day. There's no way to delete the extent. The only way to delete the extent would be to actually come up here and completely destroy it, whatever data is on it, etc., etc. Alright, let's go back to our presentation. Let's talk a little bit about multipathing, and then we're going to come back to the VI client, and I'm going to talk to you, show you how we can do multipathing here. So what's multipathing? Alright, so in ESX and in virtualized environment in general, one of the most important components, if not the most important component, and I told you this before, is storage. Because everything resides on the storage. And the way we access this storage is either going to be via some fiber channel HBAs, iSCSI HBAs, or software initiators, etc., etc. Now, getting to the storage is a critical part. You want to make sure that you always have a backup route, just in case the initial route fails. You'll have a secondary or a plan B, a backup route to get to your storage without affecting performance. Because if we're going to be using virtualization for enterprise class production environments, then we got to make sure that these systems stay up, and we got to build redundancy in them that stay up, because we're putting 20-30 VMs on a host. We don't want to lose access to these VMs or make sure these VMs stay up just because an HBA went bad or just because something happened. So we want to create a lot of redundancy within the environment to help make this a stable environment and make it run as optimal as possible. Now that being said, multipathing is the ability to utilize multiple paths to access a unit of storage. So with ESX, you have native multipathing. You don't need the installation of any third-party software to make this technology possible or these features possible for you. ESX supports 3 different types of multipathing, most recently used, fixed, and round robin. vSphere 4 introduces the pluggable storage architecture, which is basically a framework that manages simultaneous multiple multipathing plugins. So what that means is today, VMware provides by default the native multipathing protocol, or NMP. That's what VMware provides with its software for all of the storage arrays that are supported on the VMware hardware compatibility list. But the pluggable storage architecture, what it does is it opens a door for third-party manufacturers, especially storage manufacturers, to introduce their own multipathing plugins. So what the pluggable storage architecture will do again here, so for example you have a Hitachi and you have the regular VMware NMP. So if Hitachi was to write, for example, their own multipathing plugin, the pluggable storage architecture's function would be to manage these multiple multipathing plugins. So you'll have multiple. You'll have the VMware ones, you'll have the Hitachi ones, you'll have the EMC, the NetApps, etc., etc. Now by default, if we're just focusing on the NMP in turn has 2 submodules. The first one is known as the storage array type plugin, and we're going to talk about that in a second. And the second one is called the path selection plugin. So with the storage array type plugins, or the SATPs, they are assigned all the operations that are related to the storage array. They have 2 primary functions. They monitor and report changes in each path, and they also are responsible for activating a passive path, for example. Now, there are 3 types of SATPs. You can categorize them in 3 types. You can have either active-active, active-passive, or local attached storage. Now, there's an SATP that exists for every type of array that is supported by VMware. Now if we move on to path selection plugin, in simple and very straightforward terms, the PSP is responsible for path selection of the I/O traffic. So by default, you get fixed, most recently used, and round robin, and we're going to evaluate each and every one of them as we move on with this presentation, but that's the main function of the path selection plugin. Now with most recently used, this approach is typically a reactive approach to a problem that happens. You're reacting to a problem, you're not being proactive here. And the reason I say that is because the most recently used multipathing policy provides failover across paths but does not provide failback. So if you have, for example, in the figure that we have shown here, we have VM HBA1 that's experiencing a failure. ESX will fail over to VM HBA2. However, if VM HBA1 becomes available again, the path on VM HBA2 will remain the active path. So it does not provide for failback here. Now, with the fixed multipathing policy, you as the administrator is being proactive by defining the order of path precedence. So again, in the figure that we're shown here, if VM HBA2 experiences a failure, ESX will fail over to VM HBA1. And if VM HBA2 becomes available again, it will return to using VM HBA2 as the active path. So you see how there's failover and failback here. So once the failed adapter becomes active again, it restores it as the active path. Now round robin is really cool. It's a new feature that works off of performance basically. So if the active path becomes saturated, then round robin, the policy round robin kicks in and fails over to a different path to alleviate some of the performance strains that the active path might be experiencing. So MRU and fixed paths only respond to failures, whereas round robin is going to respond to performance degradation as well. So by default, round robin operates under the following guidelines. So if a new path is switched when more than 50 IO requests are issued against the active path, a new path is switched over to again when more than 2048 IO blocks are issued against the active path, the new path selected by round robin uses MRU to select the target and selects any available HBA. So multipathing is critically important in any ESX deployment. And the reason for that is if you lose access to the shared storage, then you bring down the environment. So it is imperative, it is very important that you develop and deploy a very well multipathed environment, whether you're using Fiber Channel or whether you're using iSCSI. There are ways to create redundancy as far as the pathing is concerned, but you absolutely have to get to the storage, because if there's any interruption in reaching the storage, then you're going to just crash the environment. Now as far as Fiber Channel is concerned, you can always add multiple HBAs inside of your ESX host and give multiple routes or multiple paths to the storage that way. Now keep in mind, you have some HBAs on the market today that have 4 ports on them. You have some HBAs that have 2 ports on them. The 4 ports are great. The 2 ports are great. The only problem with those is you create a single point of failure as far as the card is concerned. So what you would want to do is, instead of having a dual port Fiber Channel card, for example, have a single port Fiber Channel card but have two single port Fiber Channel cards instead of 1 dual port. That way you eliminate the single point of failure. Now you can also construct your Fiber Channel switch to have multiple fabrics. With multiple fabrics, I mean you go through multiple Fiber Channel switches. So if you have 2 HBAs, both of those HBAs in the ESX host should not be going through the same fabric. They should be going through different switches to get to the storage. That way you create redundancy at the switch level. You've already created redundancy at the ESX host level by having multiple HBAs. And the only other thing that you would need to do is make sure that when you're deploying your storage, or when you're deploying your Fiber Channel storage device, that they have 2 storage processors so that you create redundancy there too. Now as far as iSCSI is concerned, and this is very important because vSphere introduced a lot of new enhancement as far as iSCSI and redundancy. Well, with iSCSI now we have 2 ways of creating redundancy. We can have the single virtual switch multiple port groups, and I'm going to show you a figure in a second here. Or we can have the multiple virtual switches with a single port group, but they each have to be attached obviously to different physical NICs. So let's examine the figure here real quick. So you'll see on my left we have the 1 virtual switch 2 port group configuration. So in this case you have 2 physical switches that are connected to 1 virtual switch, but you have 2 port groups with type VM kernel. These VM kernel port groups will be configured to point to the same iSCSI storage, but they are reaching the iSCSI storage using two completely distinct physical NICs, multifunctional physical NICs. These can be hardware initiators or software initiators for that matter, but they are completely separated, but they're both going to the same storage. The only thing that combines them in this matter is they are a single virtual switch with multiple port groups as far as VM kernel is concerned, two physical NICs pointing to the same IP storage. Now on the right, you'll notice that we have two virtual switches. Each virtual switch has a port group with IP storage as far as VM kernel is concerned. Each virtual switch is serviced by a physical NIC, and both of these physical NICs are also pointing to the same IP storage. So in this case, you've created redundancy because on the left here, if you lose one of the physical NICs, the other physical NIC that's still pointing to the iSCSI storage is going to pick up and continue to service because there's no interruption there. It's the same physical switch. On the right, again, you're creating redundancy because you have two virtual switches that are completely distinct. So no more single point of failure as far as what happens if the virtual switch, has an issue, which I've never seen. But just to create redundancy, less headache. Two virtual switches, two port groups. Both port groups are pointing to the same IP storage. Two different physical NICs. And you're golden. We're back in the vSphere client and we want to configure multipathing now. So we're in the storage view, so we're in the correct view, and we want to try to do multipathing for prod 1, the data store prod 1. So we're going to click on properties here, and we're going to click down here on manage paths. Now you'll notice for the purposes of this example, I only have a single path to my storage. Now shame on me for having a single path. It should be multipath. Best practice dictates multipathing. So I insist that in your environments you have multipathing configured. Now if you wanted to change the path selection, it's very easy, very simple. From the drop-down menu up here, you can either go to most recently used, round robin, or fixed. Now fixed is obviously the default, and for our purposes we're just going to keep it that way. Now you can also interact with the active path or the or any other path that would show up here. Now again, we only have one path. If we had more than one path to the storage, it would show up on this list. And depending on the path selection that we've chosen, it could be active or it could just be on, which means it exists but it's not being used. Now this designates or dictates that this is the preferred path. Now if you had more than one path and you want to change the preferred, for example, you can always right click on it and select the preferred. This would make that the preferred. And obviously copy path to clipboard makes it easy if you're using tools like PuTTY, for example, and you want it to browse directly to that storage. You can just copy the path here, paste it inside of PuTTY, and boom, it takes you directly to that path. Now the disable feature can kind of come in handy because sometimes you might experience problems with a certain path and you just want to disable it until you figure it out, either from a physical standpoint or a logical standpoint, depending on where the issue is. But you just don't want that path to be used at this moment. You don't want to delete it, but you just don't want it to be used. Disable is where you can come in and disable that path for now until you figure out what's wrong and then enable it at a later time. Now obviously refresh is self-explanatory. At any time you can hit the refresh button to just refresh the most recent view. I'm going to click on close to exit out of here. That's all, folks. It's been a long module. Storage is a pretty long module, but as you can see, storage is important. It's imperative to the functionality of your virtual infrastructure. I hope this module has been informative for you, and I'd like to thank you for viewing.